So far, we have covered the popular clustering methods. There are lots of methods, so as I promised, I'm going to produce a summary of those methods. Before we do that, I want to emphasize again, clusters can be found in random or uniformly distributed data. So we have this set of random. If you use dbScan, it gives you these clusters. If you use k-means, it gives you these clusters. You use hierarchical complete link, you can produce a cluster that looks like this. So clusters, as we talked about it at the very beginning, since if we don't have a gold standard, validating cluster results is crucially important. We discussed a few methods to determine the clustering tendency of a dataset. So that's a must-do step. You cannot skip that. Because if your data is really just random, your result will definitely be just misleading. And secondly, if you use partitioning methods, so partitioning methods are used when you actually have a pretty good idea how many a rough range of clusters you expect in the dataset. If you don't, you might actually use hierarchical or density-based method to first examine those, and then probably use k-means or PAM, determined on how large your dataset is. So determine the correct number of clusters. It's easily said than done. Then if we don't know exactly what's the correct number of clusters that the data holds, then we need to spend a lot of time corroborating the result of our cluster analysis with a number of different resources. If you're lucky, if you have known results or previous studies, then you have those labels like what I have. The example of color label analysis that we're doing now. That way you have, you want to test if experts using color labels consistently, and you actually have the label. So that's a very good way that can test whether the clusters that you generate using the RGB values of cluster actually match, have clusters that represent different colors, matching the color labels. So that's one source, external known results. So we have introduced measures that can help you to measure the fitness of your cluster to known labels. And expert knowledge. If your cluster actually are highly interpretable, if you look at the results, you can identify how this cluster represents this group, and you can actually summarize a verbal description of this cluster given the values of the data points, the attributes of the data points in this cluster. It is also a very strong evidence that the cluster analysis is successful. If you don't have either of the two, then you have to use the data without reference to external information to decide whether cluster analysis is good or not. In this case, then you want to compare the results from two different or multiple different cluster analysis to determine whether they give you same results, whether some results are better interpretable than others. You could also use visualization techniques to visualize clusters. But this, as we have seen in our examples, are not none of the things that we discussed in this class is actually 100 waterproof. It always works in some situations. It doesn't work in other situations. But visualization is a good way. At least it helps you to not just feel so confident about your result. It probably confirms your confidence, but also I think most times will alert you that something may not actually fit as well as you had thought. Those are the most important takeaway messages that you want to remember. And this slides, oh gosh. Oh gosh, my recording screen suddenly went off a little bit. But you can see that I have in this table listed the algorithms and the shape of clusters this algorithm tend to produce, and what are the input parameters. So those are the hyperparameters that the user decide, and what are the limitations and the strength of the methods that we have discussed so far. I hope it's going to be helpful for you. So that's my summary. And next we're going to talk about some other topics that's related to the next chapter that we're going to cover.